I want to show you mime or kmime, the constants, something mining thing, data mine. I don't know what it's some sort of data analysis miner or whatever. I'm not really sure. I have to look it up again. But it's from Germany and it's written in Java. It's a little different. It has a little bit of problems with switching workspaces. You'll get it to crash some. But anyway, so here's the workspace for this Carolina con, and I've got a CBS reader here. Let's see if we can pull out. It's not pulling up. Let's close all these things in the background. Make sure I'm not on another window. Yep, so here we are. Configure. There we go. Now we're talking gas. So here we're going to go down and look at those progs, where we've got the CSV file we created earlier. It has a column header. I'm not going to save or anything. I'm going to cancel. I'm not limiting any rows, and you can kind of see the result here. And it looks very similar to what we saw earlier. You remember we noted that there was something was wrong with this min chroma vector 5. So let's take that out with this column filter. It's like no big deal, yada yada yada. It's literally pretty simple. You select all the filters and you say which ones are going to be over and the other to the output. This is kind of like a visual tool. This thing's built on something called Weka. I've never used it, but supposedly it's pulling stuff from there. It has MATLAB extensions in it. I don't know anything about it. But here's our labels. So we're going to create our gameplay to be blue because we're going to look at it in MATLAB in a second. And our soldier is red, so that's okay. And just make sure that's blue now. Okay. Yeah, that's fine. Partitioning, so we're going to use this little tool to build a decision tree learner, right? And we're going to do a 60-40 split of our training and learning data. We're going to draw randomly. I'm just going to have it on seed, so it's the same each time. Our decision tree learner, well, it comes up automatically where this is the one that's your two classes, so it's going to say, oh, that's the label that is for that row. The quality measure, Guinea index, I don't remember the exact definition, but you'll see that a lot. Pruning method, MDL, I don't know a lot about that, but I know that's one of the things you pick. So minimum number of records per node. So what it's going to do is it's going to look across all the different things, and he's going to say, if I were to split all the different features, explicit. If I were going to split on just one of those features, and then I was going to look at my result to see like which had the greatest number of corrections, right? All the maxes were over here, and all the mins were over here, all the class A's over here, all the class B's over here, yada yada yada. When I get down to I want to have it at least split on 8. Okay, so we got like 14. So like, we only got 14 of one particular item. We don't know how many's in this split, so 8's about right. Probably we can change it even lower, and we'll have more splits. But I really don't want to have like an overfitted graph, so let's go with this and see what happens. Simpler is better. My belief is it gives us it's less for us to compute as well, right? So this is like the majority class decision, right? And this, I think you're just saying the same. I did add a column to say like what's the probability of it being in that class, and let's run it. All right, and let's first off, we remove that. I guess it's just show it, but we'll go right to this. Let's look at the classified data. So we're going to go all the way to the end. And by the way, let's look for min. There's 4, or we remove 5, so 5's gone, right? So we don't care about any of this. But let's look here at the end. So remember our first 14 were soldiers, and our next 53 are gameplay. And this is on this split. Maybe I've selected something, but let's see. It's showing our probabilities. So, and then it's showing what it predicted it as. Let's pull this over. See if we can make some of these smaller so we can make these bigger. So let's slide. Okay, so there we go. I think there's a way to do like a score. I remember we did that in class. I don't remember how to do it, but there's a score mechanism that you can see these in the table where you'll see like an error. But anyway, so here's, we've got soldiers was our label, and our predictor is a soldier. We have some gameplay that were predicted wrong. They were predicted as gameplay, but in reality they're a soldier sample. And then it looks okay to here. And then it's got the reverse problem. It's a gameplay, but it's a soldier. And here is definitely a gameplay, and it's a soldier. And then here is a gameplay and a soldier. And what's odd is the probability is 8. It seems like it's higher to be a soldier. So we know like we've got some right and some wrong. There's another way to look at this, which is this simple tree. And so he's saying based upon having everybody, the first thing I want to do is I'm going to look at max spectral roll off. And did I screw up my colors or something? Yes, I did. I hit the wrong thing twice. So what is it? We want to have gameplay as blue, and we want soldier to be red. Alright, so let's go back. And let's run it again. You can see it, how it's thinking on these things. But may not. It's supposed to go all the way through. Let's run them. If you don't select anything, it'll go. Alright, so now let's look at this classified table. Yes, now we've got red and blue. I think this is for just the training data, the test data. But here is the big one. Okay, yes. Okay. So he's saying if I split at a max spectral run, this is good, right? Because first off, the feature that it's identified is something a little simpler. I think this is a time. I can't remember if this is a time or frequency, but it's look it up. Table, but I think that it's not one of those like MFCCs and stuff. Is going to be complex. So let me look at this again. Spectral roll off. Yeah, spectral is spectrum. So this is a frequency thing. See, like you take a DFT and then you calculate this. It should be a lot simpler than trying to calculate 12 MFCs and of one of those is one you're going to look at or something, which I don't even know. All right, so now let's go back to MATLAB where I got it up, and let's kind of look at this. So I'm not trying to train anything, I'm just pulling it in. And let's see here, he's saying max spectral roll off, if it's greater than 0.3, then it's a soldier. So I'm going to pull up the mean. Oh, actually, let's pull it max. It's actually max. So let's pull it max. Max spectral roll off. So max spectral roll off. Here we go. And this thing can be anything, but let's leave it at mean ZCR. Now let's look at, for min spectral roll off, a 0.3. 3. So it's about here, right? Maybe there. So let's see what that value is. That's a 0.315. So that would be anything from here over. You would classify. And so let's know how to get rid of that dot once you select it. But anything over here would be we're going to classify as a soldier. However, you notice you've got some of these other guys that have that high value. So it's going to be good and bad, but if you're going to call it, that's probably where you want to, right? Right at that edge. Maybe it would be, it's odd that it's not closer this way, but it could have been like where the samples were picked out. And most of these are just gameplay, so that's not bad. I could play with that.